Hey guys, Tiny Maths here, helping you improve at maths one step at a time. In this lesson, we're going to show you how to find the highest common factor of two numbers by using a method called prime factorization. If you don't know what prime factorization is, then I've linked to my video which has the title What is Prime Factorization in the description box, and I'll also link to it at the end of this video. It'll help you better understand what's going on in this lesson. We'll look at two sets of numbers. We'll first find the highest common factor of 60 and 30, and then the highest common factor of 1750 and 1120. I'll cover the basics of common factors first for those of you who need a reminder of how to find them. But if you want to get right into the examples immediately, then skip to the times you can see on screen. I put chapter indications on video so you can just hover over the video and click on the chapter you want to get to. Let's quickly review common factors. A common factor exists where, if you have two different numbers, there is a number that can divide both of them. The factors of 6 are all of the numbers from 1 to 6 that go into 6 or that can divide 6. They are 6, 3, 2 and 1. Here's another number, 9. The factors of 9 are 9, 3 and 1. If you compare the factors of 9 to the factors of 6, you can see that 9 and 6 both share a factor, 3. So we call 3 a common factor. It is a factor that both numbers have in common. We didn't include 1 here, even though it divides both numbers, because 1 divides all numbers, and that doesn't help us find the highest common factor. What the highest common factor of two numbers is should be obvious. It's the largest of all the common factors. Here's another example. The factors of 60 are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30 and 60. The factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 30. Can you spot the highest common factor of 60 and 30? Well, they have several factors in common, 2, 3, 5, 6, 10, 15 and 30, but we want the highest of these, and that's 30. So 30 is the highest common factor of 30 and 60. But notice we had to write out and compare several numbers while trying to actually remember the factors of 60 and 30 before we could pick out the highest common factor. What if you had large numbers? 1750 and 1120 for example, and you were required to find the highest common factor of these numbers. You would have to work out the factors first, and that is by no means easy. It could be quite time consuming. Thankfully, prime factorization makes this a less painful process. In today's lesson, you'll see how to use prime factorization to find the highest common factor of any two numbers, especially large numbers. Let's look again at 30 and 60. We can find the highest common factor without having to figure out all of the factors of each number. Let's use a factor tree to factorize 30 and 60. Let's start with 30. 30 equals 2 times 15. 2 is prime, but 15 is not, so we can factorize that further into factor pairs. 15 equals 3 times 5. And now you can't factorize 3 or 5 any further. Now we just multiply together all of the primes we encountered. That gives us 2 times 3 times 5 equals 30. So that's 30 in prime factorization format. Now we do the same with 60. 60 equals 2 times 30. 2 is prime, but 30 isn't. So we need to factorize that. But we just saw how to deal with 30, so let's take the result we got from the prime factorization of 30 and apply it here. Now we can multiply all the primes that we get from 60, and that gives us 2 times 2 times 3 times 5 equals 60. So that's the prime factorization of the number 60. Now look at our two numbers as they are rewritten in prime factorization. 30 equals 2 times 3 times 5, and 60 equals 2 times 2 times 3 times 5. Before, to find the highest common factor, we were looking for factors common to both numbers, and in particular the highest factor that both numbers have in common. But we do something different when looking at products of prime factors. We need to look for products of factors common to both numbers. So for example, 2 times 3 is a product of factors common to both numbers, so is 3 times 5. But we want the largest product of factors common to both numbers, and that's 2 times 3 times 5. That equals 30, which was the answer we got when using normal factors and looking for the highest common factor. Essentially, we're looking for a product of factors that belongs to both numbers, one that has the largest possible value, and that's the value of your highest common factor. Another way of seeing this is that you are looking for pairs of numbers between the two prime factorizations. Once you've found all of your pairs, you take one of each pair and multiply them all together, and that gives the highest common factor. Any factors that aren't paired are excluded from the multiplication. Now let's see how this can really help when you have larger numbers. Earlier we mentioned the numbers 1750 and 1120. Let's find the highest common factor of these two numbers using prime factorization. So let's start with 1750. 1750 equals 2 times 875. Now 2 doesn't divide 875, neither does 3, but 5 does. 875 equals 5 times 175. Since, like 2, 5 is prime, we can't factorize it, so we move to 175. 5 divides 175 and we get 175 equals 5 times 35. 5 also divides 35 and we get 35 equals 5 times 7. Both 5 and 7 are primes, so we stop there. Now we just multiply all the primes we encountered, and that gives us 2 times 5 times 5 times 5 times 7 equals 1750. Now let's do 1120. 1120 equals 2 times 560. 560 equals 2 times 280. 280 equals 2 times 140. 140 equals 2 times 70. 70 equals 2 times 35. Now neither 2 nor 3 go into 35, but 5 does. 35 equals 5 times 7. And now all we have to do is look at the primes that we encountered and multiply them all together. So we get 2 times 2 times 2 times 2 times 2 times 5 times 7 equals 1120. Now, to find the highest common factor of both numbers, we must first look for pairs of numbers. Now, there is only one 7 in each factorization, so we can pair them, and there are no more pairs of 7 left. There's only one 2 in the first prime factorization, so we pair it with 1 in the second, and there's only one 5 in the second factorization, so we can only pair it with 1 of the 5s in the first. No other pairings are possible, so we have 3 pairs: a pair of 2s, a pair of 5s, and a pair of 7s. Now we take one of each pair and multiply the result together, and that gives us 2 times 5 times 7, which equals 70. So 70 is the highest common factor of 1750 and 1120. It would have been significantly more difficult trying to find all the factors of both of these numbers in order to compare them. So prime factorization makes the job much easier. Why don't you try some large numbers? See if you can actually find the individual factors of the numbers and find the highest common factor that way. Then try, with the same numbers, prime factorization. You will find it less work and easier to find the answer. Well, that's how you find the highest common factor of two numbers using the prime factorization method. there will be one more video in this series where I show you how to use the highest common factor to simplify fractions using prime factorization to find the highest common factors. Don't forget to check out my prime factorization video and also the video on how to find the lowest common multiple of 2 or 3 numbers. During the second part of that video, we use prime factorization to find the lowest common multiple. I'll link to both videos here. And don't forget to like the video and subscribe to the Tiny Maths channel so you can receive notification of new maths lessons. Well, hope you enjoyed today's lesson. That's it for now. Until the next time, take care.